So since we have understood the process capability, CP and CPK, so we'll do a practical demonstration on CP and CPK and let's understand. So CP's formula is USL minus LSL upon 6 standard deviation. Okay, so let's do this here. Process capability. Okay, so let's say I have a LSL of 150, USL of 200, and my standard deviation is, let's say, 25. Now I want to calculate CP. As you know, CP says the inherent capability of any process, by its design. That is what it means, the process capability by nature. So if you want to calculate CP, the formula says USL minus LSL, okay, and which is 6 divided by 6 standard deviation. So standard deviation, if I multiply this by 6, so this is 6 standard deviation. So 50 divided by 150 is a 0.3333 is my CP here. Okay, so which is less than a 1, which means it's not a good design by its good feature by its design, so which is not the required enough. So it means that the upper specification limit and lower specification limit is lesser than 1. Okay, let's take another example. Here it is 200, 225, and standard deviation is 5 here. Okay, so USL minus LSL, 225 minus 200 would be 25, and 6 standard deviation, 5 into 6 is 30. So my 25 divided by 30, you can see it's 0.83. This is also good, but not as 1. So it is pretty near to 1, but not 1. Okay, so let's take another example here. My LSL is 150, USL is 200, and my standard deviation is 3. So USL minus LSL is 50. So it's 50, and 6 standard deviation would be 3 into 6. It's 18. So 50 divided by 18. This is pretty good. This is awesome. This is a perfect example of the CP that we have. It is greater than 1, which is 2.777. So which means this example, wherein my lower specification is 150, upper specification is 200, and my standard deviation is just 3. With this particular design, my CP comes to be 2.78. So that's perfect. Okay, now we'll calculate the CPK. What is CPK? CPK is the potential process performance by its design, not by design, but what actually it is. So to do that, we first have to calculate CPU, which is USL minus mean upon 3 standard deviation. I'm just putting the formula here so that we don't have to go again and again. Okay, so to calculate CPK, first of all, we have to calculate CPU. So CPU is, let's take the same formula. So first of all, calculate CPU. So USL minus LS, so we have to have mean here also. So let's say the mean here is 100, this is 200, this is 150. Okay, so just examples. So CPU, so USL minus mean, so USL is 200 and minus mean is 100. Okay, 3 standard deviation, so 25 into 3 is 75. So CPU is USL minus mean upon 3 standard deviation, so 100 divided by 75. So 1.333 is my CPU, and now I have to calculate CPL. This is mean minus LSL. Okay, so mean is my 100 minus LSL is 150, so it is kind of negative, so this is not possible. So we have to give something like 75 here. So that becomes 25. Okay. And my 3 standard deviation is already 75. So 75. So it says mean minus LSL upon 3 standard deviation. So sorry. So 25 divided by 75, it's 0.33333. Okay, and the CPK says whichever is minimum between CPU and CPL is my CPK. So 1.333 is my CPK. So that's how we calculate CPK. Let's take another example here. Okay. So mention here as 180. All right. So to calculate CPK, first of all, we have to calculate CPU. So CPU is USL minus mean. So USL here is my 225 and my mean is 200. Okay. And 3 standard deviation is 5 into 3, which is 15. Okay. So it says USL minus mean upon 3 standard deviations of 25 divided by 15. This is 1.6667. And I'm going to calculate CPL. CPL says mean minus LSL. So mean here in this example is 200 minus 180, and 3 standard deviation we've already calculated, which is 15. 20 divided by 15, which is 1.333. So here the CPK, which is the minimum. Sorry, here also we would have considered the minimum. My bad. It is 0.33, and here the CPK would be 1.33 here. That's what is CPK that we have learned, and thank you so much.